Problem 73, set matrix zeros. We're given m by n integer matrix, and if any element is equal to 0 in that matrix, we have to set its entire row and its entire column all to zeros. And here are a couple of examples here. So in this example, there are 2 zeros in these corners, and in the output, you see columns and rows are set to 0, right? Now, importantly, we're told that you must do it in place. You must do it in place, which means we cannot allocate another matrix like this to kind of help us with this zeroing things out. And you'll see why this is important. This is important because say if you were to try a naive approach in place, so inside this matrix, that would be, we would go through each element in the first row and then each element in the second row. And then in the third row, let's say we encounter a 0 somewhere. So we encounter a 0. So at this point, we kind of pause this traversal and follow basically this prompt, the problem description, that if you encounter a 0, then just set entire row and entire column to 0. So we pause traversal and just set entire column and entire row to 0. And then we kind of resume traversal. So we move to this element and try to test whether this element is 0 or not. And obviously we find that, oh, this is 0. But not necessarily because it used to be 0 from the beginning, but we just set this to 0. We just zeroed out this entire row. And also this one. And also when you come to this one, this will also be deceptively 0. And this will be a 0. And this may or may not have been 0 initially, right? So we've lost important information. Now we do not know anymore whether we should zero out this column or not. So this naive approach will not work, right? So if you're working in place, then there is already some problem here. And they say we cannot allocate another matrix like this. But what if we allocate, what we could do? We could just go through this as before, but don't pause for zeroing out rows and columns. Don't do it. Just if we find a 0 somewhere, just mark this row and mark this column as one that has to be zeroed out, and just continue, right? Then we say come here. Again, we mark this row and this column to be zeroed out in the future. So we could call these annihilation markers. Let's call them annihilation markers. Ominous name. Something from the Alibaba and 40 bandits or 40 or whatever. Okay. Right, but for this, we would need to allocate, well, maybe not a matrix, but at least an array like this. Yeah, and an array like this. So if our matrix is width and height, then, this matrix will keep annihilation markers for those rows that need to be zeroed out. And this other, did I say matrix? This array will keep annihilation markers for those columns that need to be annihilated, zeroed out. So this is fine, but still, can we do better? I mean, without allocating these arrays either, because that would, even though we avoid memory complexity of h times w, Now we have memory complexity of h plus w. And ideally, we want to bring it down to 0.1. So constant memory complexity. Can we do that? And one way to try to do this is, instead of allocating this memory here, can we just use one of those columns? Yeah. So this would be, instead of this thing, we could use the existing column, one of those. But if we're going to use one of those columns, why don't we use the first column? So let me just say, well, I am going to use the first column to store annihilation markers for each rows. So this one. And same for all of the columns. I am going to, but you know what? That is actually wrong. So this is where I need annihilation markers. Annihilation markers. This is annihilation, a different color. And this will be where I'm going to, different color, please. Annihilation markers for all of the columns here. So what's going to happen is, let's say I find 0 in this position. Let's say I find 0 in this position. Now, I have to put some sort of annihilation marker here and here. Let's first decide what should be the annihilation marker. What can I can't put here 7 or 15 or something. The best annihilation marker seems to be number 0. Why? Because, well, this row and this column has to be zeroed out anyway. So nothing else would work, because if I put any other number, that could be part of, then I would have trouble distinguishing that number from a valid occurrence of that number in this column. But 0 is fine, because whether the 0 is, because 0 is the actual final proper value, you have to zero out this entire row and this entire column. So to put 0 as an annihilation marker seems a decent idea, I think. So let's put 0 here. And let's also put 0 in here as annihilation markers. So that means we're going to annihilate this. So we are going to go through this entire bit, this entire array, in order to put annihilation markers in the right places. Yeah? So we put zeros as annihilation markers here. Okay. So afterwards, we can go through this and this. And wherever we find 0, we could annihilate this, or zero out entire row, zero out entire row. Same for columns. But what happens with so what happens with this value? What happens with that value? And also what happens with these rows themselves? So, for example, this could initially contain a 0. Now, that's not an annihilation marker, but that means we have to annihilate, zero out this entire column. Okay. Now, I cannot zero out this entire column in the beginning, because then that would be horrible, because that would then mean I will confuse them with annihilation markers. So I'm going to zero out everything later. in later steps. So what do I do with these initial zeros if it's here? Well, what I could do is I can have a variable called, let's say, first column has 0 and first row has 0. So I can set this to true or false depending on whether it actually has 0 or not in this column. And now that one should start from here. And also that one should start from here. So the first row and the first column, the actual row and actual column, the entire row and column has 0, then this will be set to 0, and so will be that. Okay. So I think we know what to do. Step 1 would be set these variables. Step 2, go through basically double loop. So row from 1 to width, like that. Column 1 to height. Sorry, I got this wrong. So row goes from 1 to height. And column goes 1 to width, exclusive. That's step 2. Step 3, I will go through these and annihilate appropriate rows and appropriate columns. So 0 out, let's call it. Step 4, column 1 and row 1 have special consideration according to these values. Yeah, I think I know what to do now. Okay, I need, oh, sorry, I just can't see this. Oh, I need this function. And I'm going to take this function to TypeScript Playground here. What should I do with this thing? So I said I'm going to have let first row has 0. I'm going to set it to false. First column has 0, also false. Now let's go through first row. For let column equals 0. Column is less than width, and we need width. We need width. Plus plus col. Let me create width. So constant height and width would be, height is matrix length, and width is matrix 0 length. And because I used matrix 0, I have to check whether if not matrix length, that means this would be undefined and this would throw an error. So that's an edge case that I'm considering. Just return. So if this is 0, that means matrix is empty. Nothing there. So we have to return. Okay. So let column equals 0. Column is less than width. Plus plus column. If not matrix, I'm looking at the first row has 0. First row has 0. So row 0. So if, sorry, first row has 0. 0 col. So if that is 0, then we would say matrix What am I doing? So I'm going through this. All right, not matrix. I need first row has 0 is true, and also break out of this loop. No need to keep going. Now, for let row equals 0, row is less than height, and plus plus row how do we spell height? Yeah, that's how we spell height. Okay, so what do I do here? If now I'm going through the first column. So if not matrix row dot 0, this is first column. If it has 0, then that means I would do a couple of things. First column has 0 is true, and just break out of this loop. Okay, that completes the first step. So after this first step, these two variables are properly set. The second step is basically going through this entire thing, right? This entire thing, trying to mark rows and columns for annihilation. Yes? So I would do for let a row equals 0, row is less than height, plus plus row. Yeah, not from 0, but from 1. Yeah, that would be incorrect if I were to go from 0. Not necessarily incorrect, it would just be unnecessary. So if I were to check this row, yeah, that would be pointless. Not necessarily a mistake, but it's just a pointless thing to do. And then same here for let column equals 0, column is less than width, and plus plus column. So we are going through this part of the array. And we're going to ask if not matrix row column. So if that is basically 0, that's what we're asking. If it is 0, what we have to do is two things. So matrix row 0 is matrix row 0 and matrix 0 column would be 0. So by this, I've just set row and column. So I've just set annihilation markers basically for all of these. Okay, that's our step 2. Let's fold this. Now, step 3 is go through each row. So step 3 has 2 parts. Go through all of those, and see which rows need to be zeroed out. So I have to go through for let row equals, where should I start? Row equals what? So I should start from here, because if I start from here, and this accidentally contains a 0. So I'm going to 0 out this whole thing, which will mean that later when I go through this second part, I'm going to 0 every column out. Okay, so I cannot touch this now. So let row equals 0. No, row equals 1. row is less than height plus row. And here I'm going to say if matrix row 0 is a 0, then I am going to zero out this entire row. Or let column equals 0, column is less than width plus column. Not from 0, because 0 is already 0. So I'm going to say matrix row column is 0. And then for let column equals 1. So now I'm going through, this. So column equals 1. Column is less than width and plus column if not matrix 0 and column, then for let row equals, so I'm going to now zero out in entire column. Row is less than height plus row, matrix row and column is 0. That's my step 3, right? There's 3. Zero out these things. And now step 4. Step 4 means basically whether this column and this row needs to be zeroed out. Okay. Wow. So many little things that look exactly the same. It's easy to confuse something. So if first row has 0, if first row has 0, then we have to zero out the first row, which I could try to copy this from here. This time I should start it from 0. Column, and this should be, yeah, so first row will be zeroed out. And if first column has 0, then you know what? If first column, then first column has to be zeroed out. And this is this guy. Again, start row from 0. And we're talking about 0 at first column. Yeah, that is it. Okay. It would be a miracle if I haven't made some goofy mistake here. Submit this on pretests. Try this on pretests. Okay, accepted. Okay, keeping fingers crossed. I've submitted, and I have to keep fingers crossed because it's, oh. So not very fast, huh? Accepted. 200 test cases passed. So memory, well, in terms of runtime is quite poor. So runtime is poor. Well, that could be because we're just using very little space. So we're not allocating any extra matrices or sets or anything. So we are going through a whole bunch of other loops and everything, which is understandable. So here, time complexity is OMN. So probably let's analyze our time complexity here. OMN, and memory complexity is, I don't know how this will calculate a memory complexity. 01. Yeah, we have 01. So it looks at the additional memory, right? Not the memory not the total memory used by the test. Yeah, it's just 01. So we have good memory complexity. Still, we didn't beat everyone. So what additional? So we are using height, width. We could have skipped using this. First row has 0. First column has 0. Column and row, these are just local variables within loops and nothing else. So this 2 and this 2 and also row and column. So about 6 6 variables. Okay. All right, so I understand why this isn't blazingly fast, because we went for memory complexity 01. That's the reason. Okay.